Hello, beautiful people. Future me. Let's get into it. I changed my typing layout again, so let's see how it goes. It is still, well, the layout is the same, but the way I switch the layouts is different. Now default is this one, and I have to press and hold down this yellow key to switch to this layout, and press and hold this one to be on this layer. So we'll see how that goes. Anyway, let's go. Excuse me. There is a room for improvement. Anyway, let's continue with something in here. I will pick randomly. Typescript. Okay, I'll do that. Code examples. Um, unknown, that is like NA if I remember correctly. We can assign unknown to anything? Can we? Oh, let's try. Yep. So that's an error probably. So we have a user name with name string, then we are get user and we are getting user. We are outputting user or undefined. So this will be I see. This will be a mirror. This how is this called? That's the conditional chaining, I think. Numbers, number. This one is okay. 1, 2, 3. String. Okay, this is an error. What? There's a string. Oh, it's type error. I forgot. TypeScript, not error. Type error. Okay, now type error. String AB3 type error. We have a number and we are trying pointing string to a number, so this is a type error. Do return that as well. Type error. Unknown is 5. Then we have any, which is equals to n, and then we are assigning any to a number. Any can be assigned to a number, so this will be 5. So what next? Any, and then we assign it to user, yeah, and unfortunately this will work for the same reason. This will mirror like so. Avoid. Void cannot be undefined, right? void can have only void or can. Oh, it can has a value undefined. I forgot. This is a syntax error. Unknown, and then okay, so this is good. This will get us the number because we do the type check in there. And what we have a function f void is not a number, so this will be type error. Now we have a user, and user returns user or null. Here returns the null, so we will get undefined because this optional chaining returns undefined. It's if it doesn't get anything, if it gets null or undefined, I think. Name string user in user, and then we are returning user or undefined, so we will get undefined as well. False. Okay, so this one returns first value, which is not undefined or not null, so this will be false. We'll complete the code. Use any. Use any to make the code below compile, even though it's wrong. Use any. Okay, so yeah, right. So they want me to commit this any. Null or one. So this will well. So call us C. Something to complete. Use unknown to make this code stop compiling. Okay, so that will be unknown. Okay, so bum bum bum. Unknown, like so. I'll take second chance. Okay, so we cannot assign unknown to a number, so this is a type error. Then we have a string. We have a strings. We are trying pointing numbers, which is type of number, to something which is type of string array. So this will be type error as well. Void is undefined. Okay, so this will okay, and finish. Some another thing, another review. So we add one, takes number, outputs number. Then we have a myAdd, which has this different signature. It takes in number but outputs a string. And that is, it looks weird to me. I'm still not quite used to that. This is the type definition. The indicator is here, the colon. And this is a type error because of the different signature. to return to, okay, no types, it's kind of okay in here. Function return class diff var, this is syntax error. This does not make sense in TypeScript. Okay. Function add takes number, outputs number. Then we are defining my add one with the type, which is the same signature as there, takes number, outputs number. Okay, here is one thing which is noticeable to me, and that is like the difference in the syntax. Like this one has like in the function, you just say this, like you write a function and then you fill in the types. Here would be the and, so you would select colon and number, and after the bananas, you would say colon and number. But when you define the type as a function which returns that, you use the fat arrow here instead of that. Okay, but otherwise this is okay, I think. Okay, I have something to choose from randomly, so I will randomly choose using JavaScript. Seal. Oh, come on. Seal. There was a free. Oh, come on. One. Okay. Type predicates. Oh, that is a long lesson. Look at the bar up there. In most cases, the JavaScript filter function works as you'd expect in TypeScript. For example, when we filter an array of numbers, we get back another array of numbers. However, there's one case where filters type can be very annoying. Imagine that we have an array of string or number, or union number. Is this the union? I think so. We want to use filter to get just the numbers, discarding all of the strings. Okay. We can do it, but the result will still have the type string or number, even though there are no strings left in the array. If we try to assign that array to a variable of type number, we'll get a type error. When there's a type error, you can type error. Okay, so this is, so we will get here the numbers like so. Then we have there numbers and strings. Then we are trying to assign the type number union string to a number, and this is type error. This might seem contrived at first glance, but it comes up often in practice. For example, what if we want to remove all of the undefines from an array? We can do it and get the right values out. Here's a code problem for you to go. What contrived means. Okay. Made up, maybe. Um, Filter all undefineds out of an array. So filter, and we will take number, and we will output number. No, 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 no. Type of number equal like so. But the type of resulting array is still undefined or number. Like is still how did I set it? Unification? Like before trying to put it in an array of type number will cause a type error. Sure. So we have that, we filter it out. Okay, so this, oh, they use it without quotes, that works too. Does it work for a number as well? So this is type error. We are going to fix this filter problem by the end of this lesson, but to start we have to step back a bit. We already seen a way to narrow types, type cards. Type cards like if type of name numbers equals the number then something. In the next example we narrow the type of a single value from number or define the number that allows us to assign it to a variable of type number. So we have a maybe number, okay, and this is a number. If type maybe number, oh, is a number, then that else. Okay, so and we put in what? Maybe number is a function which outputs 1. Okay. Oh, and we invoke it as well. There's an iffy, so we will get 1 with the defined type. So we'll get 1. Inside the if type of maybe number equals number, the compiler knows that the variable must be a number. We can write a filter numbers function to do this for a whole array. It will use the same kind of the type guard shown above wrapped in a loop. So we will put it to a new array, maybe. In this example, you'll want to push the numbers into the array whenever they are not undefined. Don't try to use a filter for this. We are still working up to that. Okay. Write remove undefined in array in a loop, I guess. Function that removes all undefined from array. Okay, so we will have if, and that will be type of maybe number equals to number. Then we will put it in. So we will say numbers push, and we put maybe number like so. Then we'll close it, and we should return it, right? So we'll close the for loop, and here will be return numbers like so. That works. That function works, but it's verbose re-implementation of filter. It would be much nicer to replace the entire function with something like numbers that filter not undefined. We can do exactly that by writing our own type guard function. We've seen type guard functions before. Array is one, for example. In the next code example, we use isArray to narrow the type to number array on the if side of the conditional, and also narrow it to number. Use isArray really, to narrow the type number on the if side. Okay. So what do we got here? We have the number or array, which gave us, I see. We'll print out the n. The n is 1 right now. So it will be this, and I'll try to predict their steps. Maybe they will be taking out the elements, pushing it. Maybe. It might seem like the Typescript compiler has special knowledge about array, but it doesn't. Instead, the type of isArray uses a feature we haven't seen yet. Type predicates. It tells the compiler if array isArray returns true, then argument passed to it is definitely an array, and you should treat it as one from now. I think I saw it, but they might change the lesson. We can write our own define type guard function that decides whether a value is undefined or not. That will let us cleanly solve our original problem of filtering out undefineds in array. For simplicity, it will only handle arguments of type number undefined. Okay, so we have a function defined. maybe number. It takes maybe number or undefined. And the output is what? Maybe number is number. I never seen the is keyword, at least not in TypeScript yet. So that is a new one to me. What does it do? And it returns Boolean. Is number. Okay. Okay, I see. So that returns Boolean, which tells us that it is a number. So this could be, I could also check for the type and equals to number. Okay. Now the new syntax here, maybe number is number. That's the type predicate. It lets our function be used as a type guard. It tells the compiler that the maybe number has the type number even outside of this function, but only if defined returns true. If defined returns false, then the compiler gets no new type information. What is this color scheme? I kind of like it. We call our defined type guard as normal function. It returns a boolean telling us whether its argument is defined or not. Okay, so this one will return true, false. We can also use defined as a type guard, just like we did with array is array. Okay, so it is a function. It should return boolean, and the return type the name of the variable is number. Okay, it ties those two things together. The variable name and that one. Okay, maybe you can have more input parameters and then choose one of them is of defined type, or maybe multiple ones. Who knows? So we've got one, so this will be a one. Now we have undefined, so it will output 0. We can only use defined as a type guard because we added maybe number is number to the function's definition. Normal Boolean functions without a type predicate won't act as type guards. The TypeScript compiler can't extend type guards to other functions. Here's an example that seems identical to one above, but we wrapped defined in another function. It won't compile because the function has no type predicate. Like maybe number is number. Okay, so what is it? We have defined two. Well, first, maybe number, that still gets us the same thing. We have a undefined in there with type, union type, number undefined. And then we have a defined two, And we have a... Okay, so that is a maybe number. Type. Union number or undefined. And then we output defined. And defined is the function we wrote above. Okay. That's the function above. This will not work as a type checker, you say. Okay, so this will be type error. Then I see. Our define function lets us write the simple filter call. That was, compilers can't extend type guards to other functions. Mhm. Our define function lets us write the simple filter call that we wanted at the beginning of this lesson. And the function below, remember to pass the defined function directly to filter as an argument, like filter defined. You wrap it in an error function like that, then the wrapper won't be... If you wrap it in an error function like that, then the wrapper won't be in type guard, just like the define to function above wasn't a type guard. Use define function to filter the array of numbers, removing all undefineds. The resulting array will have the type number array because defined is the type card. Filter, and we will get defined. Is this how you do it? Number. Okay, this is not it. How else could I write it? Maybe numbers, filter, and then I say use the define function to filter the array of numbers, removing all undefined. Well, I would do this. I would do this, that, defined, and put n in here. And this one doesn't work, he told me. Can I do just define like so? and I cannot wrap it in a function. So I would do maybe I could just write it in here. That's the thing I would think about, like, and that will be number or undefined. Then it will return n is number. And then just return the thing, which is an that will be not equal undefined. Line terminator not allowed before, okay. Well, this one works, but that's I did not use the thing, and I don't know how to use it. I just rewrote it again. Use the defined function. Okay, I did not. I want to repeat this. If I reload it, what happened? I will start from beginning, okay. So we will blast through it. So this is type of number. Okay, so it will get us 1. It will get us 1 and 2, like so. What is this? Number. This is type error. And now I will complete something. What? Remove all undefineds. Filter all the undefineds out of array. Okay, so we will get a function, and that one will take n. It will take n, then the output will be type of n equals number. Like so, and I will close it. Okay, what is this one? Okay, so this is type error. And here, okay, we have a number undefined one, maybe number. Okay, so this one gives us one. There's something for write a remove undefined function that removes all undefined from array of numbers. Okay, so this is if type if type of maybe number equals what was it, number, then we will do something about it. We will add it to numbers, so numbers dot push and maybe number, like so. Close, I'll close that guy. So it is no closing. Okay, closing. Return numbers, like so, and to close it. Okay, that works. This is, they are asking, so we have an array that will take the first thing, one, some another thing, defined one, so this will return true, false. It says defined, maybe number. So, and we have a number, so we will get one. Here we will have 0. So we have, this one is wrapped in, so this is the type error. And now this is the problem I was trying to solve. So filter, and I want to use the defined thing, but I cannot wrap it. And I have to provide a function. So like this. This refers to the function, right? Oh, that's it. That's it. That's good because okay, so the problem or the realization I just had is that I have to provide here the function, and if I put in defined, it will just take this entire thing and put it in, right? So okay, that's good. I got it now. So what's next? There's a bit more going on behind the scenes here. Typescript authors wrote filters type definition with type guards in mind, enabling us to use them to do this kind of filtering safely. The full details of filters type signature include other TypeScript features that we haven't seen yet, but you can look at this type if you are curious. there's a lot to read. Not now. Oh, fuck. I closed it. Okay. So let's blast through it. Filter. So this is one, two, close. This is takes numbers. This is type error. Means right filter all out. Okay. So filter, and we will take n, and we will return true if it's a number. So type of number equals number. I will close this. Okay, that works. What else? So here we have number undefined. Then we are filtering that. We cannot assign that. So this is type error. What else? So here we have a 1. What do I do? Write remove undefined function dot remove all undefineds. Okay, so if type of maybe I don't like that, so we will do this. Okay, we'll delete you. You will be M, and now M equals number. We will append it. Numbers push M, close it, and return numbers, close that. Okay, so here's that. Then we have here this, here that. Oh, okay, I see now. So I go here, at X, don't give it there. Okay, and now I close it here. That should do it. So this one returns 1. Defined 1. Oh, that is no, that is true, false. 1, 0. Type error. Find get. Okay, so here is type guards are a great place to use unknown. For example, we might want to write an isString type guard. It wouldn't make sense to make it take an argument of type string. If the argument is definitely a string, then there's no reason to call it isString in the first place. Yeah, sure. So there's an undefined, and this will be true, false. Is unknown. If it is string, it will return s. Otherwise, yeah. So this will be a string. That will be this, and I have a problem to complete. Write is number. Okay, so it takes n, which will be unknown, and will output n not in, but is number, like that. Okay, and here will be the definition of the function, and we will say return a type of n equals the number, like so, and we'll close it. It works. TypeScript blindly trusts us to implement type guard functions correctly. If the function itself is wrong, then the types will also be wrong. They'll still be fully enforced, but the compiler will be enforcing the wrong types. Be careful with this next example. It's intentionally wrong in a way that the type systems can see. So there's an unknown. It says it is a number if it is a string. Okay, so oh no. And this number that will return yes, so we will have oh no and 2. Our best advice is to heavily test our type cards with an automated test suite. That way you'll have more confidence about the type guard itself, which will allow you to trust the type system as a whole. Finally, a note on terminology. A type guard is any expression that we use to narrow a type. There's 3 important cases. Okay, type guard. First is the if statement. The strict comparison is a type guard. The TypeScript compiler has specific hard-coded knowledge about the strict equality operators types narrowing properties. JavaScript and TypeScript don't support user-defined operators at all, so we can't add new operators that narrow types. Second, if array is array A is the isArray function call is a type guard. The type definition for isArray is distributed with the TypeScript compiler, but it's written using normal TypeScript using the method that we saw in this lesson. The actual type of isArray is okay. Any an argument is any array. I see. You can also see it in the TypeScript source. That's interesting. I will have a look at it. As that its array type shows, it's possible to write type guard. I want to see now. Is array. What is this? Okay, so there's a constructor. Is there the definition of the function? Is array. It's only in here. That's interface. Where's the implementation? Okay, that did not help much. It says arg is any. There's no body of the function. just the type, okay. As that isArray type shows, it's possible to write type card functions with any instead of unknown, but isArray only uses any because Typescript didn't have unknown when the type definition was written. We recommend using unknown over any for your type card functions. Thank you. Third, when using our own isNumber function with if isNumber and the isNumber call is a type card. This is the same as the isArray case above, but here we are defining the function ourselves. The piece that we added to the function definition and isNumber is called a type predicate. The type predicate turns the function into type card as type predicate. Okay, and that is a type card function type function letting it narrow types. Otherwise, it would be a regular function that returns a boolean. Okay, and we are done. We are done. Way overdone. And done is better than perfect. Even though this was awesome. And I'll see you next time. Bye.